Hello, my name is Erik Vedeler, and I am the head of the Electromagnetics and Sensors Research Branch here at NASA Langley Research Center, and I've been working here for about 22 years. I originally got interested in NASA and the types of work that NASA does way back in the 60s when the moon shots were going on, and I distinctly remember in 1969, in July 20th, when the first human being set foot on the planet, the moon that we know of today. That was a very, very exciting time for me and very, very inspirational. My grandfather also worked a little bit on the space program, so he was a big influence in my life at an early age. Here at NASA Langley, I've worked on many aircraft and spacecraft antenna design projects. I'm very, very interested in how radio waves propagate and how they scatter off of objects in our environment. This is a kind of a core science area. A big project that I worked on here at NASA was the design and construction of a huge lab about the size of a basketball court. And in this lab, we can measure something the size of a BB with a radar. So it's a very, very, very exciting thing. There's a lot of interesting technologies that we developed in that lab that we've spun off, and you can now find them in industry around the country in various places. So that was a very, very exciting thing for me, and one of my big, big projects, since it really is big. One of the things that's very exciting for me to do is to lead research and researchers here at NASA Langley Research Center in the quest to make airplanes safer. We have a large amount of aviation safety research going on in our branch, and particularly we use radio waves and lasers and LIDAR, something called LIDAR, that we can detect atmospheric hazards. And some of these hazards are things like wet and dry microbursts, which are like thunderstorms, where you have big, big downbursts of wind. Things like volcanic ash. Many of you may remember last year that they had to shut down part of the European skies there to airplanes because of the volcano in Iceland. So it's a big, big problem, and we're working on sensors that can detect and mitigate, help us avoid these kinds of problems. Another big area is in lightning research. We've done a lot of lightning detection and how they interact with systems on aircraft. A lot of times airplanes have to fly through thunderstorms, and we would like to know how those airplanes can deal with lightning safely and not have a problem for the safety of our flying public. Probably one of the most exciting things is working with people that are just as excited and passionate about aviation safety and space as I am. That's a very, very exciting part of my job. And we would like to make the traveling skies as friendly and safe as possible for everybody. So some lessons I learned in school. I very much enjoyed taking a lot of my math, physics, computer science, and engineering classes as an undergraduate. And these are all very, very necessary classes and things to understand in order to solve problems in our complex, technologically driven environment in today's world. Aircraft have gotten very, very sophisticated. We have lots of wireless devices. Probably many of you carry around cell phones and have ways of communicating with texting and so forth with all your friends. And so we need to make sure that those things all work together well and safely in our environment, especially in our aeronautics environment. So we want to know how those things behave. The skills that are needed to advance our understanding of our environment for the 21st century are embedded in science and technology, STEM courses, as you may have heard that term. And I look forward to having a virtual visit in your classroom. Thank you.